Question number 11. Here given set is set of points in the plane. Defined relation is this. Ordered pair P comma Q, that is P related to Q, if distance of P from origin is same as the distance of Q from the origin. So for example, this is origin here O, and somewhere your P, and this is Q. Then this distance and this distance both should be same. This is the question. So we first show that it is an equivalence relation. It's an equivalence relation. So we are given here P related to Q if and only if distance of P from origin, that is P O, equals to distance of Q from origin, that is QO. Here O stands for origin. Now first property is reflexive here. So clearly for reflexive property you need to take same. So if I put P here and again P here, then PO equals to PO. So clearly you can say that P comma P is a member of relation set R as distance of P from origin is same as distance of P from origin for any point P, for any P. So because of this here R is reflexive. Second, symmetric property. You know meaning of symmetry. You start with A related to B and you show that B related to A. This is the meaning of symmetric property. So I'll start with this. Suppose P related to Q. It implies you can say that the distance of P from origin is same as the distance of Q from origin. Now you want to show that here Q related to P. So it is same as you can write like this: distance of Q from origin equals to distance of P from origin. Just have changed the side. It's like this: distance of P from origin equals to distance of Q from origin. Distance of Q from origin equals to distance of P from origin. Both are same. And this is true for every PQ. So therefore you can say that R is symmetric here. R is symmetric. So R is reflexive, symmetric. Third, transitive property here. So again, let's recall. Transitive property means you start with A related to B, B related to C, and with the help of this you show that A related to C. This is the meaning of transitive property. Start with this two and get this. So I'll start with this. Suppose P related to Q and Q related to, let me take third point, T. Now this means distance of P from origin is same as the distance of Q from origin. This means distance of Q from origin is same as the distance of T from origin. So it's like this in a diagram. If this is origin, then distance of P from origin it's same as the distance of Q from origin, and distance of Q from origin is same as the distance of T from origin. If this is 3 unit, then this is also 3. This is 3, then this is also 3. So these two distances are equal. So from these two you can say that distance of P from origin is same as distance of T from origin. So therefore we can say that P is related to T. So P related to Q, Q related to T. It implies you could show that here P related to T, and this is true for every P, Q and T points, and therefore you can say that here R is transitive. Here R is transitive, and therefore relation R is an equivalence relation. Is an equivalence relation here. Now in this question further you are asked all points related to point P. So this is origin. Now P is at some distance from origin. Now as per the definition, if I take any point here Q, now if Q is related to P, then this distance of Q from origin is same as this. So if this is for example 2, then this must be 2. If I take third point here, for example T, if T is related to P, then the distance of T from origin is same as the distance of P from origin. If I take another point here, if this point is related to P, then the distance of this point from origin is same as the distance of P from origin. So if I find all points which are related to P, all points related to P, point P is, you can see that it is such points. These are the all points which are related to P. Why this point is related to P? Because distance of this point from origin is same as the distance of P from the origin. So all this collection forms, you can see that the circle. So here I can write all points related to P is the set of all points in the plane which are at the same distance from origin that of point P, and this collection, this points or this collection, this point forms the circle, forms a circle with center at origin. Center at origin. I repeat this portion. Here you want all points related to P. So if Q is related to P, then as per definition, distance of Q from origin is same as the distance of P from origin. If I take another point which is related to T, then the distance of T from origin is same as the distance of P from origin. So that way if I collect all such points, so if this is for example R, then this is also R, this is also R, this is also R. So this forms a circle. So here what I've concluded is all points related to P forms a circle with the center at origin and radius equals to OP. So here radius becomes this much OP, that is the distance of P from origin. Question number 12. Here is set of triangles. Relation R is defined in this way: T1 related to T2, that is two triangles are related if they are similar. We'll show that, as we have shown number of times, it's an equivalence relation. So first property is here reflexive. So in reflexive property you need to take one member with itself. So here clearly T1 comma T1 will be member of R. Why? Because T1 is similar to itself, similar to T1. You can write symbolically like this if you want. T1 is similar to T1, and this is true for every triangle T1. Every triangle is always similar to itself because they are identical triangles, and identical triangles are always similar triangles. So here R is reflexive. R is reflexive relation. So second property, that is symmetric. So in symmetric we know we start with A related to B. With the help of this we'll show that B related to A. This is what we want to do here. So suppose for two triangles, suppose T1 is related to T2. The meaning of this one is same, remember, T1, T2 belongs to R. Both are same things. I'm just telling you for information. Whether I write this or this, both are same. Now what's the meaning of T1 related to T2? It means T1 is similar to triangle T2. Now, if T1 is similar to T2, you can say that T2 is also similar to T1. Similar means ratio of the corresponding sides are same. So here T2 is similar to T1, and therefore you can say that T2 is related to T1, and this is true for every triangle T1 and T2 belongs to A, you can write. So therefore here R is symmetric relation. Whenever T1 is related to T2, you have shown that T2 related to T1, and this is true for every triangles T1 and T2. Now third property, that is transitive property here. So again recall transitivity. You start with this supposition, A related to B, B related to C, and with the help of this you show that A related to C. If from this can show this much, then it is called transitive relation. So here we start with this for three triangles. Suppose T1 related to T2 and T2 related to T3. Therefore you can say that T1 is similar to T2. This is a symbol for similarity. And T2 is similar to T3. Now similar means ratio of the corresponding sides is same for T1 and T2. T2 is similar to T3, that means the ratio of corresponding sides of the T2 and T3 is same. So from this you can say that T1 is similar to T3. This is always true. If ratio of corresponding sides of T1 and T2 is, for example, 2, then ratio of T2 and T3 would be something else, for example. Then again T1 and T3 ratio remains same. This is always true, remember. So what you have shown, and this is true for every triangles T1, T2 and T3. So you had started with T1 related to T2, T2 related to T3. Here you have shown that T1 is similar to T3. So therefore T1 related to T3, and R is transitive, and therefore R is an equivalence relation. R is an equivalence relation. R is an equivalence relation because it is reflexive, symmetric and transitive. Further you are asked here, out of 3 triangles. So you have triangle T1 with sides 3, 4 and 5. The another triangle T2 with sides 5, 12 and 13. Third triangle with sides here 6, 8 and 10. Now clearly you can see that ratio of the corresponding sides of this one, that is 4, T1 and T3, ratio of sides, that is 3 by 6, 4 by 8, 5 by 10. Each of this one, you know, it is 1 by 2. So here ratio of the corresponding sides is constant, which is 1 by 2. So therefore T1 is similar to T3, and therefore you can say that T1 is related to T3. But this is not true. T1 is not related to T2 because there the ratio is not same. Even T2 is also not related to T3 because their ratio is also not same. Only for these two corresponding ratios, if you look at it, it would be just 1 by 2. Therefore T1 related to T3, but T2 is not related to T3. T1 is not related to T2. Question number 13. Here A is the set of all polygons. You know, polygons means closed plane figures, maybe triangles, rectangles, rhombus, anything. Now here definition is two polygons are related. P1 is related to P2 if they have same number of sides. We again show, as we did number of times, we show that this R is an equivalence relation. R is an equivalence relation. So we show that it is reflexive, symmetric and transitive. Your first property is reflexive. So which is again very clear. If I take polygon P1 with itself, for reflexive property you need to take with itself. Clearly P1 comma P1 belongs to R. Why? Because P1 and of course P1 same polygon. If this is triangle, then this is also triangle. If this is rectangle, then this is also rectangle. So P1 and P1 have the same number of sides. The same number of sides, which is quite obvious. So you can say that P1 is related to P1 for every P1 belongs to A. That is for every polygon P1. So R is reflexive. This is a reflexive relation. Second one, we go to symmetric property here. So symmetric means you start with A related to B and show that B related to A. Start with this and get this. So we start with this. Suppose P1 is related to P2. I can write like these also, remember. P1, P2 belongs to R. Meaning is same as I mentioned earlier also, again in this sum also. Both are having the same meaning. You can use this or this, any one of these two symbols. Now what's the meaning of P1 related to P2? So it implies P1, polygons P1 and P2 have the same number of sides. Same number of sides. This is by definition. This is given to us. P1 and P2 have the same number of sides. So it implies you can also write P2 and P1 have the same number of sides. And what is the meaning of this? P2 and P1 have the same number of sides. You can say that P2 is related to P1. And this is true for every P1, P2 belongs to the set A. That is for every polygons P1 and P2. And therefore you can say that here R is symmetric relation. Third property, transitivity. So we start with A related to B, B related to C. With the help of this, we'll show that A related to C. This is what we need to do. We start with this 2, we get this. So what is supposition here? Suppose P1 related to P2. First polygon P1 related to P2. Take same polygon P2 related to P3. We started with 3 polygons. In transitivity you need 3 objects. Now write the meaning of these 2. So it implies you can say that P1 and P2 have same number of sides. What's the meaning of this? P2 and P3 have same number of sides. Here you are saying P1 and P2 have same number of sides. Suppose 5, 5. So P2 must have 5 sides. Here P2 and P3 again have the same number of sides. If this has 5, then this must have 5. It means P1 and P3. So clearly P1 and P3 have same number of sides. So from this you can say that P1 is related to P3, and this is true for every 3 polygons P1, P2 and P3 that is belongs to the given set A, and therefore R is transitive here. So therefore you can say that here R is an equivalence relation because it's reflexive, symmetric and transitive. Therefore it's an equivalence relation. Now here further you are asked that find all polygons related to triangle T with these 3 sides. With the sides 3, 4 and 5. Now these measures of sides are not important here. Important one, you are given a triangle. So any polygon, by definition any polygon related to triangle T must have 3 sides because triangle has 3 sides. The measures of sides 3, 4, 5, that's not important here. You have a triangle, and you know even this right triangle is also not important. Your triangle T, now you know triangle has 3 sides. So if any polygon which is related to triangle, then the number of sides of that polygon must be 3, and therefore you can say that any polygon with 3 sides represent triangle. So all triangles are related to the given triangle T. I again repeat, this right triangle, it's not important. Measures of sides is also not important. Here as per definition, if any polygon is related to triangle T, then it must have the same side that the triangle T has. Now you know any triangle has 3 sides. So every polygon which is related to triangle T must have 3 sides, and polygon with 3 sides represent all triangles. So all triangles are related to given triangle T. Question number 15. Here relation R is defined on this set with 4 members given by these ordered pairs. You want to choose the correct option. Now let's try for the first property. Is it reflexive? So here 1 related to 1 is there, 2 related to 2 is there, 3 related to 3 is also there, and 4 related to 4 is there. So it's reflexive. First one. Now go to second property, symmetric. 1 related to 2. If it is symmetric, a reverse should be present. 2, 1 should be present, but you can see that 2, 1 is not there. so it's not symmetric. So clearly this is the correct answer now. It's reflexive but not symmetric. Why not symmetric? Because here 1 2 is there but 2 1 is not there. Even you can see for this also 1 3 is there but 3 1 is not there, so it's not symmetric. You can verify that the transitivity holds, so B is the correct answer here.
कर दे दो.
Relation R on N given by this A related to B if A equals to B minus 2, that is first number is 2 less than the second and B should be greater than 6. Choose the correct option. So the difference between these two has to be 2 here, and second number should be more than 6. So you can, if you try for this here, 8 minus 2 is not this, 8 minus 2 is 6. So obviously C is the correct answer. Right? Why? Again look at it this here, first number should be second number minus 2. So 8 minus 2, which is 6. And second number, remember, it should be more than 6. So you cannot take these as a correct answer. So C is correct answer. Now let's see this example number 5. Such example we have not discussed in exercises. Show that the relation R defined on all integers, that is Z, given by this R equals to A comma B such that 2 divides A minus B. That means A minus B should be multiple of 2. 2 divides A minus B means A minus B is divisible by 2. And you want to show that this is an equivalence relation. This is an important example, so let me give the solution for this. So here relation R is A related to B if 2 divides A minus B. That means A minus B is divisible by 2. Like this, for example, 2 divides 4, 2 divides 8. This number should be multiple of 2, remember, that's the meaning of this. Now here, for reflexive property, you need to take the same member, that is A comma A. If you recall, 2 divides, here you need to take difference, that is A minus A, which is 0. This is always true. Recall, this means 0 is divisible by 2. It is always true. So here I'll write clearly. You can say that A comma A belongs to R. What I mean by this, that is A related to A. So here, because 2 divides A minus A, which is 0, which is always true. So therefore you can say that A related to A for every A belongs to Z. If I take 1 here, 1 comma 1 will be R. Why? Because 1 minus 1 is 0 and 0 is divisible by 2. If I take 3 here, 3 minus 3 is 0 and 0 is divisible by 2. Difference is always 0 here. Definition is this: difference should be multiple of 2. So always true, and therefore it is a reflexive relation. Do not get confused with this. The meaning of this number is divisible by 2, and which is always true, remember. Now second property, let me write here, therefore R is reflexive. Therefore R is reflexive. Now we go to second property, which is symmetric. So we start with this. Suppose A related to B. What is the meaning of this? It means 2 divides A minus B. So this number must be multiple of 2. Now you want to show that here B related to A. This is what you want to show here. So you want to show that 2 must divides B minus A. Now from this you can write directly, if 2 divides A minus B, then 2 must divides B minus A. Why? What's the difference between these two? They are opposite. A minus B If I take minus common, it will be b minus a. So if this is 4, then this has to be minus 4. If this is, for example, 8, then this will be minus 8. If this is minus 20, then this will be 20. So if 2 divides 20, then 2 must divide minus 20. If 2 divides 100, then 2 must divide minus 100. So from this, you can always write this. And what's the meaning of this? If 2 divides b minus a, you can say that b is related to a. If you have a minus b, then you are saying that a related to b. Here you have b minus a, so therefore you can say that b related to a. And this is true for every a b belongs to z. Remember, all integers. And therefore you can say that R is here symmetric. Still, if you have any confusion, let me take one example. This is just for your information, not for in the solution. For example, you can say that 2 related to 6. Is it? Yes. Why? Because 2 minus 6, how much? Minus 4. And 2 divides minus 4. This is always true. Therefore 2 related to 6. Now you reverse. So from these you can say that 6 is also related to 2. Why? Because 2 divides, check the difference of these two, 6 minus 2, which is 4. So that's what I've tried to explain here. If 2 related to 6, then 6 must be related to 2 from this. So here you just use opposite concept. If this is 20, then this is minus 20. Like here 2 related to 6, because 2 divides 2 minus 6, which is minus 4. If this is true, then 6 is also related to 2. Why? Because here 2 divides 6 minus 2, which is 4. And therefore symmetric property always holds. So recall, for transitive property you start with A related to B, B related to C. Use this and show that A related to C. So we start with this. Suppose here A related to B and B related to C. What's the meaning of A related to B? It means by definition 2 divides A minus B. What's the meaning of this? 2 divides B minus C. Now actually this is a property of the division. Let me write here. For example, 2 divides 4, 2 divides 6. Then property of the division says that this 2 divides always the sum of these two, that is 2 divides 4 plus 6, which is 10. This is always true. If I take one more example, 3 divides, for example, 9. 3 divides 6. So from this you can say that 3 always divides the sum of these two, that is 9 plus 6, which is 15. This is always true. So I'm going to use this property. 2 divides A minus B, 2 divides B minus C. So using this property you can say that 2 divides the sum of these two, that is A minus B plus B minus C, sum of these two. I've used this concept. 2 divides A minus B, 2 divides B minus C. So 2 must divide sum of these two. B will get cancelled. So here you can say that 2 divides A minus C. And therefore you can say that here A related to C. And this is true for any 3 numbers A, B, C belongs to Z. 2 divides A minus C means A related to C. Therefore R is transitive. So what you have shown here, R is reflexive, symmetric and transitive. Therefore R is an equivalence relation. R is an equivalence relation. This relation here, this relation is called congruence modulo 2. Congruence modulo 2 relation. Modulo 2 means 2 divides A minus B. Congruence modulo 2 relation. It is also denoted by this. It is also denoted by this symbol, denoted by A, then this three lines congruent to B, bracket inside the bracket mod 2, like this. Right? This means the meaning of this is 2 divides A minus B. That is what we have discussed. 2 divides A minus B. This is called congruence modulo 2 relation. Now here there is nothing special about 2. You can have 3, then in that case 3 divides A minus B. You can have 5 also, then in that case 5 divides A minus B. This modulo number always divides the difference. That's a property. So in case if you're asked for instead of 2, 3, 4, 5 anything, then you can give the same proof. So in general A congruent to B, I can write mod small m, where m is any positive integer, remember. It can be 2, 3, 4, 500. So this is called congruence. This is called congruence modulo m relation. Congruence modulo m relation. It means m divides A minus B. For example, here, if I write, for example, you can say that 4 is congruent to, let me write 1 here, modulo 3. Why? Because what is the 4 minus 1? 3. And 3 divides 3. So this is just one simple example.